All right, perfect. Well, why don't we dive in? Thank you everyone for making it. My name is Lukas Fittl. I'm the founder and CEO of pganalyze. And today we're going to talk about pganalyze MCP in action. We're going to look at how we can optimize our Postgres with Claude and other AI tools. We'll, go through some practical examples. During today's session, if you have questions, there's a Zoom Q&A feature that you can use. So just, put questions in there, and then we'll probably get to most questions in the end. But if there's something really unclear, I do keep an eye on the Q&A tab. So if I see something, I might jump to it, but otherwise expect it around the end. I think for today's session, we'll probably run for about 45 minutes to an hour, including Q&A. So, definitely welcome all kinds of questions and input. And then we'll also send you the webinar slides as well as the recording tomorrow. And if there are any questions that we didn't have time to get to today, you'll also get them in your inbox tomorrow. So feel free to forward that email to your colleagues or anybody else who's interested in this topic. And if you have any other interest in talking more about this, at the end of the webinar, you'll also get a survey. In the survey, you can let us know your feedback, but then also feel free to reach out to us or to me personally on the email address here on the slide if you have any other questions or want to talk more about how to use pganalyze, for example. All right. Well, today I want to talk about basically 5 things. So I want to first talk about what the pganalyze MCP server for Postgres is and how you use it, right? Like just some, kind of ground up, what's it doing, what's it for, why do we need it? For context, I've worked with Postgres for, I want to say probably 20 years now. I think 2006 was the first Postgres server that I, had to deal with. Always as an engineer, basically, right? So like in the very beginning, I was the application engineer who had to, basically write an application that was using Postgres. And over the years, my personal understanding of Postgres grew, which ultimately led to, starting pganalyze. But, kind of why I like talking about this stuff is because I think we as humans have a role to play here. And I don't just want to, show you all the fancy features, but I do also want to talk about kind of the human impact or the team impact of having these new tools and how we can actually use them effectively and safely. So I'll talk a little bit about that in the pganalyze MCP server in the intro. Then I'll give you an example actually how I optimize Postgres performance. I felt that this would actually be a good grounding to show you my personal thinking, because I think it's really interesting to basically think about hybrid approaches, right? Where we contribute something as a DBA or as an application engineer, and tools like Claude can, do other parts for us. And so I want to start basically with just showing you how I optimize a query, how I optimize a Postgres performance problem. And then I want to switch to basically Claude doing the same thing. And then we'll, kind of lead a little bit into more of a hybrid approach of how, the two can, collaborate basically. And we'll show you kind of what we mean when we say tuning loops, specifically with the pganalyze Workbooks feature and the MCP server. And then at the end, I'll close with just a few thoughts on, where I think these things are going, where this is going for pganalyze, and of course also for Postgres more broadly, right? So for context here with pganalyze, we offer a tool, we offer a product for Postgres, but we also have, interest in making sure that Postgres itself evolves over time, because that benefits us, benefits our customers. And so, all of this is intended to basically make us use Postgres better. All right, so let's start with the pganalyze MCP server. So if you haven't, read about it or you're not familiar, maybe first of all, worth noting, what does pganalyze do, right? So pganalyze captures monitoring and performance data from your Postgres database. And we really emphasize that this should come from your Postgres production database, right? So other tools might work, during your development cycle, but pganalyze historically has really worked more on the, your production environment, whether it's on Amazon RDS or in a self-managed virtual machine, an on-premise data center in Azure. Like, we support all these different environments, and we basically pull out critical kind of performance data. We pull out, indexes being used, indexes that are missing, all this kind of information from Postgres. Now, the way we structure this in the context of the MCP server is we basically have this component called the pganalyze collector. The collector runs in the production environment or close to the production environment, and basically pulls data from the production database. Now, this is, restricted access, right? So it has, in Postgres, you have PG monitor as a role. We basically use that as a baseline, which lets us capture things like query statistics, like which queries have executed, query plan information using auto explain, kind of all these different data points. And then we send that data into the pganalyze workload repository, or just pganalyze basically. And that's really the key part of how this flow works, right? So if you're looking at some other, Postgres MCP servers, the role of the MCP server is just to basically be a proxy between the MCP client and the Postgres database, which is still useful, right? Like it's still better than having, like if you just have your Claude Code just execute pSQL directly, like that's a big problem, right? Because you're kind of, you don't want to give it production access in that case. And so Postgres MCP Server in general helps you, abstract that access better. But with pganalyze, we've really gone a step further and said, we don't just abstract the access, we really keep historic data about what happened on the Postgres database so that we don't have to go to the production environment to get information, right? We'll talk later about workbooks. Workbooks are actually a little bit of an exception to this diagram here. So this diagram here is more for the monitoring data. With workbooks, which we'll show later, it's more of a kind of inverted control flow still going for the collector. Now, when we see on the left here, right, like we have MCP clients like Claude Code, we might have, Claude on the web, we might have OpenAI's tools. It really doesn't matter to a certain extent, right? I mean, we want the model that's good at tool calling. So for example, one thing I've seen myself is like when I was using, just for testing, I tried using ChatGPT. Like ChatGPT can connect to MCP clients now or MCP servers, but ChatGPT is actually really bad at tool calling by default. Like the harness they give and the instructions they give, and probably also the model that they use by default is just not good for tool calling. Versus if you use Codex or Claude Code, those are much better at kind of instructions and kind of getting data and doing something else as a follow up. So worth pointing out that you want to make sure you have a good, basically, model there. There was also a question, maybe I'll actually get to this right now because it's relevant. So Bhavik asked a question just now, does the pganalyze MCP server also store information on the data itself or just the performance data? So for pganalyze, we've actually chosen just to store mainly the performance data. We do store statistics, right? So for example, we store information like how big is a column on average, or how many records are there, but we don't store the actual data, right? So like that's actually an important abstraction. So if you don't want your MCP client, like your Claude Code, for example, to access the actual table data because it's customer data, with pganalyze, we actually let you abstract that. And just a quick, summary here in terms of the tools that exist, right? So, I mean, we're talking about things like getting query statistics, getting table statistics, getting backends we call wait events, and you can get explain plans. This is really, I think, one of the key tools actually that I've found to be useful is if you give an AI tool the ability to get an explain plan from production database, it basically multiplies what they can do, right? Because it's like they're good at pattern matching, they're good at, kind of finding kind of the signals in the noise. And so being able to give an AI tool explain plans is really easy, basically, with the pganalyze MCP server. The other thing, just to show you an example, right? I find kind of, Claude Code is always hard to show because it's just very text heavy. So we'll have a mix of, text heavy screens and non-text heavy screens here. But just to show an example, right? Like I can use the MCP server to ask really simple questions, right? Like my database is slow. Why? Right? Like, please help me. And, otherwise you might have, this might be, I don't know, might be the engineering manager going to the DBA asking, can you help us figure out why database is slow? Versus with the MCP server and, a tool in place that queries it, we can ask simple questions like, it's slow? Why is it slow? And then it can basically go in and pull this data for us, right? And we also see here roughly in the middle where it says, let me pull the key data in parallel, right? Let me pull the issues from pganalyze, the top queries, the server details. So it's able to basically look at all these different data points faster than a human could usually. Sorry, I asked a question whether this is an add-on product. So this is built into pganalyze. So just for context, the pganalyze MCP server is available for everybody who uses pganalyze on any of the pganalyze plans. PII filtering is the other key part here about the MCP server. So we had a question earlier about, kind of does this actually have the actual data? So it doesn't have the actual data, but you would still have potentially parameter values. And so one of the things that we really built into the MCP server is the ability to filter out parameter values as well if you don't want them there, right? So there's kind of a choice. But oftentimes, if you have really sensitive data in your production database, even just what you're querying by, right? Like it might be an insurance number or a social security number, credit card number, worst case. Like that kind of information might be in a where clause. And so PAI filtering is basically a way for pganalyze to filter out where clause values so that you don't have that data in pganalyze. And then you also have the data removed from the MCP server. So just, some quick principles that we found useful for us, basically, kind of when we looked at this, right? Like we want to have control. We want to make sure that, you control as a user, you control when LLMs are called. You can always turn things off, right? Like it's basically something where it's not, the magic thing that happens, but rather, it's the thing where you can say how you want to use it. We, place a heavy emphasis on authorization, right? So for example, in pganalyze, some organizations might have hundreds or thousands of database servers, but you only want to look at a particular server. And so you always kind of, scope it down to a user if it's an interactive experience. And then also filtering, as mentioned, is important for us. Now, a couple of things just in general on the MCP server that we've added. So first of all, the MCP server, we initially released it in early access at the beginning of the year. It's been public preview since April this year. So if you sign up for pganalyze right now, you can just use the MCP server directly. And then we also added the ability recently to use API keys for basically more agentic workflows. So if you have something running in the background that isn't really tied to a user, not tied to an interactive session, you can call the MCP server using the API keys in pganalyze. And then also we've added new tools recently around log insights specifically. So pganalyze captures log data from Postgres as well. We won't talk much about that today in the interest of time, but just if you are interested in basically asking your Claude, for example, hey, has there been why has there been a rise in unique constraint violations? And then you have the data in the pganalyze logs, and Claude would actually be able to pull out that information with the new log-based tools. Logs are also still subject to the filtering, right? So we can still filter out the sensitive data from the logs. And then really the main thing I want to talk about today, because I think it's really cool and exciting, is the Workbooks integration. So pganalyze Workbooks, I'll talk more about in a moment what that is. But basically, this is a new feature that is now in early access. So this is not yet available for everybody. But if you're interested in trying out what I'm about to show you today, let us know in the survey at the end. We're basically, working with people closely right now to iterate on that particular feature, which ultimately, the quick summary here is, gives Claude or other tools limited ability to run explain analyze. So it kind of inverts this flow, right? Like it actually goes beyond the monitoring to kind of more of a validation benchmarking approach to enable more different approaches. Now, we've had a couple of questions, which I might actually get to right now, because I think it seems helpful just to get them out of the way. So Sandeep had a question on how much extra load will this add to an RDS cluster to pull this information? So pganalyze, we've, as a product, has been around for many years. We've really optimized pganalyze to, have low overhead and do all the processing as much as possible on the server side, right? So pganalyze, think of if we maybe go back for a moment, actually, I'll just for clarity, right? So if we look at this diagram here, we look at the pganalyze collector. That's really that component that gets the data, and it basically runs statistics queries like, from pgstats and other tables to get information. And so we, would not expect this to raise the, kind of runtime or add an additional overhead, like more than 1%, I would say. The only exception that we've sometimes seen is with the auto-explain extension. If you look at the pganalyze website, you'll see more details on that. But that one is part of Postgres, but it has certain settings that you have to use to really get the right kind of, tune it right to not have overhead. So feel free to reach out if there's more specific questions there. And then Nagender had a question on if this MCP server works with the self-hosted version of pganalyze as well. The answer is yes. So for context, pganalyze has a self-hosted version called pganalyze Enterprise Server. That's basically a self-contained release of pganalyze you run in your environment. No data gets sent to our cloud, and you can, use the MCP server in that environment as well. It's part of the latest enterprise release. And then also, we recently got a question outside of this webinar where somebody was asking if it's possible to use local LLMs, right? So if I don't want to use Anthropic or OpenAI, but I want to run a local model, you could actually have a local MCP client like Pi, for example, use a local model and still call the pganalyze MCP server. So if you wanted to, this could all be in your premises based on what makes sense for your organization. And then let me see if we got any questions. Let me get to some of the other questions later, just in the interest of time. We'll get back to them at the end or asynchronously. Okay, so let's continue. So I want to show you an example of how I optimize Postgres performance, because I think it's good to set the stage, how we could be thinking about these problems. And I'll actually give you a specific example. So, maybe before we do that though, just for context on, how I like to think about organizations using Postgres, right? So a typical organization using Postgres that we see when we work with organizations is you have, a group of application teams. They're usually larger in number. And then there is a group of, data platform engineers or DBAs who are smaller in number, right? Like there's just less of them. And so, in between these two groups, the databases that, the application teams kind of want to have because their application depends on them. And the data platform team enables those applications to exist and to function well. And so really, a lot of the things that I think AI can do and help us with have to do with, the people in this diagram that, have to do certain work, right? Like application teams want to ship features, the, DBAs just want to have the database not fall over. And we all kind of are trying to just make sure that, databases in the middle are happy and healthy, basically, right? So just to set the stage, we'll come back to this diagram when we talk about where we can put the AI tools in here. So I'll give you an example here. I'll actually start not in pganalyze, but I'll start in APM tool. So this is a screenshot of Honeycomb, but the same applies to other application monitoring tools. So basically, oftentimes, when we have a performance problem, we don't actually start on the database side, right? Like usually what happens is customer opens the support ticket, customer says, the website is really slow today. And then you go in, you try to understand, okay, what happened? Why are they having a bad experience? Why is the application loading slow? Is it a recent release? All these kinds of things. And commonly what I would say you would find these days is that you would get a trace of some sort, right? So in this case, again, we're looking at a specific request that took 11 seconds. And usually when the database is involved, it's one of two things. Either a query is slow, right? So here in this example, out of the 11 seconds that this request took, 8.6 seconds were spent on, just a single query. This is a great example of where we should be looking at pganalyze, right? Because pganalyze can tell us what happened. The other example that's a little bit different is if I saw a lot of fast queries, right? So a typical N+1 type problem. So that's actually not something that pganalyze is really that ideal for, because it's more about, how do I change the application to not send the same query 200 times, versus pganalyze is really good for, I have a slow query, why is it slow, right? So here in this example, I have this query that took 8.6 seconds. Again, this is me as a human going through. I'll show you a little bit later how this looks like with Claude. And so as a human, now I basically click through. There's a way to link pganalyze data with your APM tool. So basically I was able to get to the actual explain plan here. This is what pganalyze recorded. So pganalyze recorded the runtime here of that query, 8.6 seconds. That query executed last week. And I see the explain plan here. I see all these index scans, right? So I see kind of a nested loop with an index scan on that schema tables table. And then I see kind of looping over those partition tables on schema table infos. Now, if I look closer at this query plan, right, and this assumes that I have enough skills and ability to do so, and time also, but assume all these things are true, and I go in and I basically try to understand what's going on, right? So look at the query plan. I notice that this query basically gets the data from this first table here, based on an input parameter, right? This database ID, and then if I look at the query, this kind of like the way this query is written, it has basically a lateral join combined with kind of a very simple query, right? Like it's just getting some data and it's kind of filtering. Now, the one thing I notice here is if I look at, make sure it's easier to see here. So if I look at this query, this explain plan, I see that it loops over that partition table kind of data 2,000 times. And to me, that stands out, right? Because it means that like we see the bulk of the time is kind of spent in those, partition tables. And so I think whatever is happening, right, like we should try to optimize that query on those partition tables. Okay, so one thing I like to do when I'm a human optimizing things is I just like to run explain analyze again, right? And the reason I do that is because I want to confirm that it's still a problem, and that this wasn't just. I mean, maybe the database server had a really hard time. I should still investigate that, but maybe it was something else, right? Maybe it wasn't a query plan or query optimization problem, and so I like to rerun things. Now, the first thing you see is that the performance is different, right? So we had one execution took 8,600 milliseconds. This one here took 3,300 milliseconds, so it was faster. And the really other important thing to do is to run the query a second time. So I haven't modified the query at all. I'm just rerunning a second time. And now it got a lot faster, right? Like now the query is 130 milliseconds instead of, 3,300 milliseconds. Now, why did it get so much faster? It's because of caching, right? So in the first example, Postgres didn't have the data cached, right? And so it had to go to disk. It had to get some of the data from the indexes on disk. And so that's why it was a lot slower. Here in this case, it was faster because it's all in warm cache. We can actually see that when we look back to the query explain on the top right where it says IO read time, we actually do see that the runtime was mostly dominated by IO read time, right? Like 8,200 milliseconds was IO read time. So to a certain extent, we could say, well, it's just a caching issue, right? Like nothing to do. Now, oftentimes, even though, the fast cache performance is better, right? Like the warm cache performance is better. This is still pretty slow for warm cache, right? Like a query like this taking 100 plus milliseconds, to me usually means it's overfetching data in some way or form. And so if we optimize the warm cache performance, that will also help us optimize the cold cache performance, usually. And so that's what we're doing here, right? So we're looking more at data here. We're looking at the table definition in pganalyze. We see in this case, I was kind of trying to understand, which indexes exist, right? It's an indexing problem. I see that these, the tables basically that it was looking things up on, they're looking things up in that schema table ID there. There is an index for that. So, I mean, that seems fine, but it is still kind of a nested loop, right? Nested loops, by themselves can be a problem because we're doing in this case the same thing 2,000 times. Now, the other thing I did is I looked at the table definition, in this case also in pganalyze. And so in this case, I saw that, there's kind of many different columns. But what was interesting to me here, knowing this data model, is that there is this server ID column. And the server ID column is actually something that, is indexed per the previous page. And more so, when I look at the query, I know that for each database ID, there's a given server ID, right? This is context that I have. We'll see a little bit later that this is context that might not be as obvious to Claude. But anyhow, I have this context, right? So I, as a human, basically went in. I said, okay, server ID, we should be able to query by that. We should be able to add that into the query. And so I changed the query, right? Like I basically modified the query and said, okay, let's filter by the server ID, right? Roughly in the middle here. And then I run the query again, right? Just another explain analyze. Now, worth mentioning, well, first of all, this query didn't get faster. In fact, it got slower. So, whatever I did here wasn't good enough. But second of all, I'm doing this testing on production or on a copy of production. Because if I did this locally in staging or my local development environment, I wouldn't have the actual, performance, right? Like I wouldn't, like the tables are much smaller. And so this is part of the challenge here, like why, is a human doing this versus AI doing it? Because AI doesn't have the capabilities usually, right? Like I can't just go and do an explain analyze here. Since this didn't get faster, I was like, okay, let me iterate a little bit more. So I went in and I basically changed the query. I moved some of the lookups into a CTE. That didn't help either, didn't make it fast enough. But then I realized Postgres actually ignored my CTE. Like I wrote a nice CTE, but Postgres was like, I know better. But then I changed it again because I was like, well, Postgres, I know better. I have an idea of what I'm trying here. And so at the very top of the query where you see as materialized, that's basically me specifically forcing Postgres to load some of the data first to then loop over it, right? So my intent here, just to summarize, is I was trying to get Postgres to not loop 2000 times and do index lookups 2000 times, but instead get all the data for the server, which includes the database ID I'm looking for. And then Postgres can basically, just do lookups on the data in memory, which is much more compact. And the good news is, I optimized this query and it got a lot faster, right? So now it only took 5 milliseconds instead of 130 milliseconds. And we can see that basically, in that CTE basically loads the data once. And then in the nested loop, towards the end, we see CTE scan, and it basically just loops over that data in that CTE scan. Now, this is something that I've actually talked about in previous webinars. So if you're interested in this kind of style of debugging and how to do it better as a human, I basically talked about this in some of our career performance webinars previously, and it's really kind of a basic loop, I would say, and we'll get to the more fancy version of this loop in a little bit. But the old school human version of this loop is I have a slow query, I benchmark the query with explain analyze, I form a thesis on what to change, I try out the change, and I benchmark it again. And once I figured out that it's actually faster, I make the change permanent in some way or form. And that's, I think, a really, if you have been a DBA for some time, you'll obviously be familiar with this. But that's, I think, really the fundamental, activity we're doing, right? You call it a human tuning loop, basically. So this took me, when I, ran this yesterday, it took me like 45 minutes to go through, but this was because I knew the data model. I knew this kind of problem. I could totally see that, somebody who's maybe less familiar with this probably takes multiple hours or, multiple days potentially if it's like really complicated queries. And that's actually a problem, right? Because it means that we can't always do these things. Like it's actually pretty expensive for us to do time-wise, attention-wise. And so even though oftentimes in production systems, we have these opportunities to optimize, we, don't necessarily do it because it takes a lot of time. And then the other thing I want to point out, just really quick before we move on, is if we look back at this diagram here, who is doing this work, right? Like who is doing this query optimization work? I think in my experience, it's either a very motivated application engineer or more commonly it's, the seasoned Postgres DBA data engineering person who's just done it a lot. And so for them, it's kind of obvious or it's easier to do the work, right? And so there's basically an accessibility problem here because the application teams that would be able to probably do the best job if they had, the experience because they know the data model, they usually don't do this work, right? Like usually this kind of tuning work is more on the right side of this diagram. And I think that's, often the challenge basically in reality why, queries stay unoptimized basically. So yeah, let's go forward a little bit. And yeah, let's see what Claude can do, right? Like if I got from 138 milliseconds to 5 milliseconds, can Claude do better? So let's look a little bit at this. So first of all, when I say Claude, I mean Claude Code. I mean, in this case, Opus 5. I've personally not found much difference between Fable and Opus and other models. I mean, certainly, if you use Sonnet, I can perform worse, but I feel like most of the time, I think the state-of-the-art models are pretty similar. So you probably get slightly different results, but I don't think it matters a lot whether you switch the, effort to high or super high in this particular example. It's more about the data that we make available to the models. Okay, so I basically said, I have a specific problem here, like this, like imagine basically I looked at the diagram in Honeycomb, I was like, okay, this must have been a customer's bad experience. And I was like, here's the trace ID, can you go look it up, right? And you'll see actually in the connected MCP servers, I have a bunch of MCP servers connected here. Obviously, I have like pganalyze 5 times in different variations. And then I also have Honeycomb and Sentry. For context, both of them are application monitoring tools. Today, we're looking at Honeycomb's MCP. Same would work with Sentry's MCP. What I've really found is that combining multiple MCPs and combining the data from these MCPs makes a lot of sense, right? Like, again, a database-specific tool like pganalyze might know really well why a query is slow, but it might not know that the query gets called 100 times. And so knowing, getting this tracing data from an application monitoring tool really makes a difference. Now, on the other side, if you only have the application monitoring tool, you will see the query is slow, but you don't know what to do next, right? Like you don't actually have the details of what the database did. So the combination of the two is really useful. Okay, so we go in, we ask Claude, please, find out what's happening. It finds the trace, right? Like it basically calls the Honeycomb tools to get all the tracing data. And then one key thing that we've implemented here is the ability to link the tools using a specific, tracing span on the application side, application monitoring side, where basically, you see here kind of in the middle where it says, now I can fetch the actual explain plan for that 30-second query. The reason it can do that is because it has a marker from pganalyze in the application monitoring tool, and that marker basically lets it find the backlink into pganalyze, right? And so now, based on that, span, it's basically able to say, okay, get the query explained from trace. So then it's saying, the server ID, this database, this query fingerprint at this timestamp, and that basically calls into pganalyze. Now, here I kind of skimmed over a few things just because, Claude can be very verbose and I have enough Claude output as it is. But the one thing I'll point out here is that, when it says I have the root cause, what it means is it saw the explain plan, right? Like it did this tool call where it did get query explain from trace that basically gave it the text output for the explain plan. And that text output basically, shows what's going on. And so when it says I have the root cause, it basically says, well, I see what's happening, right? Now, the other thing it's doing here is, in this case, it's pulling up the schema definition. It's pulling it up actually not from pganalyze, it's pulling it from the local repo. This is because I'm starting this Claude Code session in the code repository that the query is from. If that's not the case, or in some other cases, sometimes it makes sense to have pganalyze provide this data. So there are also tools that, Claude could use to get the table definitions from pganalyze. But in this case, it just looked it up in the local repo. And then it basically said, well, it's this query. And the other thing is, like, what's really useful is at the very end where it says this 30-second query is find by SQL in this, source location. I think this really helps us, bridge the gap between the data teams and the application teams, is that we can actually now more easily find where these queries are coming from, even if ORMs are involved, right? And then here it says, okay, root cause is a lateral join that can't prune partitions. Okay, so it basically says, well, it's this lateral join. We saw this lateral join earlier. It says there's daily partitions, 36 live ones, and it has no predicates that it filters by, so Postgres can't prune the partitions. For what it's worth, I do agree with that sentiment. It is a problem that there's no partition pruning. And then it says, this is, 75,000 index scans, a lot of buffer hits. And then it's arguing that, in the original explain plan, basically it was all IO weight, which we did see earlier as well. Then it got kind of unhappy about, every partition scan returns rows 0. So that's just because in this particular case, even though we looked at this data, this customer didn't have any of that data in that schema table infos table, which is not the case usually, but that's kind of where it went. Okay, then I kind of skipped over a few things here because it's basically, it ended up wanting to do something very different. It was like, oh, no data is being returned. Well, I don't really need this data. Let me just drop it. So I had to steer it back a little bit towards, let's actually improve the query. Like, I don't want to change the semantics. And so, the kind of, it was, trying to reason about the model in different ways. And it was trying to, again, suggest a change directly, right? So basically, one thing that these models are just like trained for, right? Like, that's how they're being reinforced, is to, at some point jump to the conclusions. And I think that's an anti-pattern for us, right? Like, as users, we should really be careful not to jump to conclusions too quickly. So in this case, it basically wanted to go ahead and make a change to the code because it saw a problem and it found the problem. And then I basically said, well, no, let's validate the change, right? So like, that was me at the very end saying, let's actually not go ahead and make the change. Okay. And this is where your experience might vary a lot depending on what you have set up, right? So if you don't have pganalyze and you don't have pganalyze workbooks, what might happen is that it will tell you to do an explain analyze, and then you might end up copy and pasting a lot of things. Here, because I have the pganalyze MCP server set up and I have the new workbooks feature, it basically on its own recognized when I say validate, it meant validate with the workbooks feature. And then it automatically jumped to saying, let's record a baseline, right? So basically what happened, and then, do a variant with kind of trying different things. And then it basically went into tool calling to achieve that. Now, this is basically where, again, this is the new part, right? So this is the part where we're kind of going out of just looking at the monitoring data and really trying to say, okay, well, how do we get these tools to try different things? So one key ingredient here is the pganalyze workbooks feature. So workbooks is basically it's a tool that we built into pganalyze to tune queries, to iterate on queries. Basically, this, you saw me earlier kind of doing explain analyze manually, and explain analyze running, manually on a production database is, I mean, it's kind of the reality. That's what a lot of people do. But the problem is you often lose context on what you tried. It's really hard to share, right? Because you have these large text outputs, like you might paste them into some online paste bin. And then, you have other problems with PI. And it becomes really messy potentially to do all this explain analyze tuning. And so workbooks are basically a way to, like have a structured approach to how you test query rewrites, to test query changes. Now, with the workbooks ability in the MCP server, we can basically have Claude actually run and explain analyze. It can't do anything else, right? So to be very clear, it doesn't actually have the ability to run arbitrary SQL without explain analyze, but it can say, run a query, analyze how long it takes, and get the explain plan result, right? Has certain security implications. We have a full, documentation page on what that means or where there are maybe problems if he's doing this. But I've actually found this a really good trade-off because we're not giving direct database access. This all is basically controlled through pganalyze. But we are, in this case, pushing the activity, right? We're saying, give me an explain analyze now for this particular query. Now, here, it first started with the baseline, right? So this is a decisive result. So, it kind of saw the warm cache experience that we saw earlier. So this is, basically the same conclusion that we had, is that the warm cache is so much faster, right? But also Claude here confirms, it's the same amount of buffer accesses that we saw in the actual original explain. So, this is all the caching state, right? It was able to confirm that basically with the explain analyze. And then it's able to create variants. And this is kind of what workbooks are really built for, is basically iterating on different versions. And so here, basically, it's creating a variant, and it's kind of saying also what it's trying, right? So in the kind of description of the variant, or the name of the variant says, this is a bounded collected add. It's trying to do partition pruning. It adds collected add as this lower bound to the lateral, so Postgres can prune the most recent partitions. It's anchored data. So one of the things that is useful here is it's not just running explain analyze, it's also recording what it's trying to do. Like, what is the attempt? What is the thesis, so to say, right? And it can get the results, right? So basically here now, we have, kind of a variant where there's a 2-day kind of look back, a 7-day look back, different variations based on what it's on the code. And then it basically, was able to go from 150 milliseconds in this warm cache run to 13 milliseconds, I think, in the fastest version there. And so this, is good. It's not as good as what I got. So, there's a difference here also in what the approach is. But it is maybe something that makes more sense than mine, right? I mean, like writing a query of materialized isn't great. But all of this work here, I mean, I manually approve those tool calls, but this is pretty safe. Like, it has a timeout, it forces a read-only transaction. So, I would feel comfortable giving Claude this automatically in the background and it just coming to me with this result. The other thing that's really great about this is that I not just get the Claude Code session, I also get this as a workbook record in pganalyze, right? So I can now go into pganalyze and I can say, okay, I got the baseline, I got, these different, kind of variations that were tried. And this is all, recorded as basically evidence in pganalyze, so that I don't have to, look back through a wall of text to summarize what we found or what we tried. I can also use tools like the pganalyze compare feature, right? So I can basically say, compare me the explain plans between those two variants to see, how they structurally differ, and where the performance benefit comes from, right? So I can basically reason about what actually happened or what the optimization is. And then what I can also do is I can make a human variant, right? So I still like to exist as a human who have relevance. So of course, I want to prove that I can do it better. And so I can go into the workbook and I can basically, using the web UI in this case, I can just create another variant and I can say, let me try my materialized, right? Like, let me do that and see how it performs using the workbooks feature. Again, with workbooks, for context, we have two different ways of running things. We have what we call the manual workflow and the collector workflow. For Claude sessions, we always emphasize the collector workflow because that's the part where it can basically run the things directly without prompting for the outputs. But manual workflow is an alternate mode in workbooks where basically you copy and paste the results. This is more for if you don't want, the automation piece, basically. And so now I can say, hey, look, my variant is better, right? Like I still got an edge against the AI. And this is also recorded on a workbook as activity, right? So I can basically see, which activities came with my identity, but through the MCP server, and which activities came through me as a person directly in the UI. Now, the other cool thing is I can actually tell Claude that I made this variant, right? So I can say, hey, I added another variant. Can you take a look at that? And then Claude can actually look at that and, try to understand why that one's faster. I could do the same by, telling Claude to try it out, right? Like it's kind of a choice that I do it for the UI, but I can also do it here in the session directly and basically propose changes. But again, the nice thing here is that we have this record of what was tried. And then Claude, of course, says, you got something right, but it's not real. And so the reason the reason it claims it's not real is basically because of those empty rows. And so then it kind of kept iterating and said, let's actually try a hybrid variant. And so basically it added one more variant to the workbook, which is basically combining, kind of a certain way of pruning down with the materialized case. And that got the performance even better a little bit, right? So it got down to 4.1 milliseconds in this case. So just to show that, in this case, we can, really try different versions and still have a record of what was tried. And then we might choose, to implement the initial 30 milliseconds version. Like that's still a 10x improvement, right? Maybe that's an easier code change to make. Or maybe we want to try the materialized version. But we have all of these, things recorded here. And then, of course, I can jump in and I can tell Claude, can you make the code change, right? And I think this is the other piece that's really important is we actually bridge the gap from, I can make the query faster to I can actually make the code change. And even though, as a DBA, for example, I might not know the applications team's database well, I can actually, I can optimize a query and then I can use a tool like Claude to really drive the change on the application side with the ORM code. So. Now, the more fancy version of this loop, right, that we also had in our webinar kind of promotion banner, is basically the same thing, but we kind of, take Claude and pganalyze into this, right? So you use pganalyze to investigate slow queries. You can form a thesis. You can use different ways of doing this. Query Advisor and pganalyze, does that. Claude Code can form a thesis for you. And then what we forgot on the promotion banner, most important, is they're humans, right? Like we want to form thesis as humans too. So, I think it's really important that we don't stop thinking, but I also think that oftentimes these tools can, tell us, is it even worth trying, right? Like, is there even an opportunity here? So we form a thesis, we draft the variants, in pganalyze, we use the workbooks, Claude can drive that for the MCP server, and then we validate the performance using an actual explain analyze, again, for the pganalyze workbooks feature. And then once we found the variant that's fast, we can actually give that back to Claude and we can say, Claude, hey, here's the evidence, we made it faster. Now let's actually ship those changes and have Claude Code make a PR or make the code change and then a human makes the PR. Doesn't really matter, right? But we basically, we compress the timeline here significantly and we have a clear way of actually getting the change done on the application side. Now, this is really part of like where is this coming from? Like, or why are we trying to do this? So this is kind of related to this concept of agent backpressure, right? Like if you want to build an agentic system, like one of the things you're trying to do is you're trying to have the AI keep iterating and keep tool calling on its own without the human having to give input. And so the problem is, for example, imagine you only gave, like you ran Claude without this and you just had it prompt you for the explain analyze plans all the time. The problem is that you're significantly slowing down the loop because you're slowing down this back pressuring, right? Like the Claude can't know what the performance was, and oftentimes it will get things wrong, but the back pressure of, the actual performance data will get it, zoned in on the right direction. So, the other thing that we didn't talk about much here, but you can do this in copies or clones of production too. For example, to verify index changes. That's something that we're currently working on. But imagine if you're on Aurora, for example, you can do Aurora clones. You can again have pganalyze workbook to test things on a clone. That's kind of where this is going. And this also can transform how organization works, right? So basically, if we get this picture from earlier, we're not replacing the data team. We're just giving everybody more, ability to do certain things, right? Like the application teams can have PR review bots that have context of production data or production sizes of tables. The data platform team can use a coding agent to understand the applications and make changes. So I think to me, a healthy organization using AI is basically we use AI tools as enablers, as multipliers of humans, right? Like we still have a human driving those changes and owning those tools. Because I think if you lose that part, then that's where kind of things go off the rails, in my opinion, right? Like you really need somebody to own the AI tooling as well. Great. I know we have a bunch of questions. I'll get to them in a second. Just to give you context on where we see this going in terms of both the broader Postgres database ecosystem and then also pganalyze a little bit. So I would say this is a diagram I used earlier the year in a different presentation on the MCP server, but I think it very much still holds true, right? I think basically most organizations are not on the autonomy, like big on the autonomy scale yet, right? So if we think on the left here, we have full autonomy, we have AI taking action on production. On the right side, we have basically AI having no autonomy. I would say maybe this, dial on the right here has probably shifted a little bit to the left. I feel like especially the startups that we work with, they oftentimes, have AI doing incident investigations automatically already. But for many enterprises, certainly, like AI doesn't have a lot of ability to do things. Now, what we don't want to do, right, is we don't want to have the DBA agent kind of take down our production. So this is really, our problem here is like, if you get this wrong, the consequences are pretty bad. And this is kind of why I think the nuance here is important, right? Like, what do we do? What do we not do? But the problem is if we don't give it enough capability, we might end up in this, I did what it said, but it's still slow, right? Like we basically get proposals, we get PRs, maybe even from, AI tools, but we don't actually test the changes before we make the change. And that's a problem. And so that's really what Workbooks tries to do, right? It's like it tries to enable this automatic testing of optimizations so that we can validate the proposed change and then make the production change. Right? So that's our kind of vision here. That's the goal of doing this, is basically shifting more left on this axis here so that we can do the right amount of autonomy basically. And just kind of where we see pganalyze in this, right? Pganalyze is really focused on Postgres specific monitoring. That's not changing. Analysis and recommendation logic. We have pganalyze advisors that can run in the background. Those actually are really important even in a world where you have AI tools, because they can run all the time, right? They can run at night and they don't consume tokens. And so we can do things like say, is there a bad query plan that we found? And then we can kick off something that actually investigates and iterates, maybe with AI tools in the picture, but we don't have to, right? Like we can basically run things that don't consume the tokens to find the problems in the first place. Now, again, with the MCP server, you can kind of access this data using third-party agents. And then one of the things we're also looking into later this year is basically having some of these flows built into pganalyze as an opt-in, right? So you can choose whether you want it or not. But we've found that, again, more on the enterprise side, I would say there's sometimes more variability on which models are available, or maybe even, do people use tools like Claude Code? And so we'll, add certain kind of workflows in pganalyze itself as well as an option. And then I think there's more opportunity here for more automation. So that's another thing that you'll see us talk more about, is basically, how can we automate some of these tedious tasks in Postgres whilst kind of keeping control over what's going on. So yeah, that's all I had for today. I'll get to the questions in a moment. If you have to leave, please take our quick survey that will pop open from Zoom basically at the end. You can note that to get early access to the Workbooks feature in the MCP server. So just for context, again, the MCP server is available for everybody, but the Workbooks feature, that one is currently gated because we are actively iterating on some of the details and how these tool calls work. We'd love to hear your feedback, right? So if this was useful, let us know. If it was not useful, also good feedback. And then if you're interested in trying out pganalyze in your organization, let us know. You can request a meeting and we'd be happy to basically set up a call with you. All right. Got a handful of questions, and if you have more questions, feel free to post them. Let's see. So, all right. So Vipin asked, do we have documentation on the pganalyze MCP server and tools available? So if you go to the pganalyze website, I'm not going to open it up right now because it's going to break my screen share. But if you go to pganalyze.com, in the docs, there is a pganalyze MCP server documentation page. It lists out all the different tool calls and some other aspects of how to use the MCP server. So that's all available in our docs. I think the URL is pganalyze.com/docs/MCP. Let me see. Okay, so I think hopefully I don't mispronounce the name. Anbazagan had a question on situations like outdated stats would be pretty common cases for poor performance. sometimes, Postgres can also switch from a custom plan to a generic plan. I think the question was kind of, like these are all contributing factors, kind of maybe I'll basically comment on how I see this stuff factoring in. So for example, what pganalyze will detect is, if a query plan has stale stats, right? So like the table hasn't been analyzed recently, we do actually show this as an insight on the explain plan. And so data like that, I would say falls into the category of, it's actually good to use deterministic logic, right? Because if you surface that logic to something like Claude, it can then jump to the right conclusion faster. So certainly in this particular case, that wasn't, the root cause, but certainly if Postgres gets, the query plan wrong, you really want to just, be sure that Postgres didn't forget to analyze the table recently, right? So I think the argument is, this kind of stuff will be found more faster, right? If we get the data in a deterministic way and surface it to the AI tools consistently, then they will, be able to actually see that and react based on that. That'll be the hypothesis. Then let's see. Yufra had a question just now. Does Databricks Lakebase support pganalyze? So we've recently added support for Neon, which is basically the pre-acquisition approach for what now is Lakebase. So I think probably Databricks Lakebase is also supported, or it wouldn't be much effort to have supported. Feel free to note that in the post-webinar survey also, and we can follow up and maybe set up a meeting or at least send you documentation on what we think would be needed. And then Vipin also asked a question, what's the average Claude cost of using pganalyze MCP? Good question. I mean, cost is always tricky here, right? Because, how many tokens are we consuming? I don't think I have a good answer for you. What I can say, though, is the more data you provide, the less tokens you will consume to a certain extent, right? Because the bigger issue that I found is if Claude keeps going, like, especially if you do like auto accept, and it just tries stuff, it's really happy to keep iterating in the wrong way. And so I think that's where the backpressure piece is so important, right? Because if you're like, you need to steer it back to the right path quickly, because otherwise it might consume a lot of tokens doing the wrong thing. And so I think that's where, it's hard to really quantify, but I think it's less about, how many dollars are you spending per investigation, and more, how can you make sure that it realizes this was the wrong direction faster? Does that make sense? And then Vikram had a question related to the agent backpressure. So just if I can explain more about agent backpressure when we run Claude just for explains. So again, I think the backpressure piece really comes to, you want to steer the agent. It's kind of like, so if you look at code, for example, right? Like the Claude, for example, is pretty good at writing code, but if it doesn't write unit tests and run the unit test, it will still write bad code even in the newest models, right? And so the harnesses and kind of the prompting or the reinforcement learning is really geared towards getting it to write tests, or at least I've noticed that for myself, because the tests actually help it have that back pressure where it then realizes it needs to fix something before making a PR, for example. And so this explain analyze serves the same purpose, right? Like the explain analyze is the test for the query rewrite, right? Like it's the way that we know that the query is actually improved and not just theoretically improved. So that's kind of the role of it. Great. And then I think we had two more questions, just a little bit long questions. Let me see if I can. Yeah, so I think this is probably a good question that might be easier in a one-on-one, but I'll Srikant ask a question comparing pganalyze with Datadog DBM and kind of asking a little bit about, index suggestions. And I think you had some more specific questions on float estimates. So we have a comparison chart of Datadog that you can find on our website. I think in this particular example, in the context of the MCP server, I would say pganalyze has more Postgres specific data and more Postgres specific tools, right? So what we found at least is that when it comes to what's my slowest query, probably you'll get similar results. But when it comes to going to the explain plan and doing a compare on the explain plan, those are things that are really different. And then also the workbooks feature is something that you don't really have in Datadog. So Datadog, for example, has a public explain tool that you could paste things in, but that doesn't really make it accessible to your AI tool locally. So there's a lot more details to this. We frequently have conversations with people evaluating both tools, and often people choose pganalyze because we're more Postgres specific. We really solve the Postgres challenges in a quicker way, basically in a more comprehensive way. But I feel like this is probably easiest if we, set up a conversation to go through it in detail. Um, and then I think there was maybe, um, let me see, there were two more questions. A little bit of time left, so let me see if I can get them. So Hendra had a question very much at the beginning of the webinar, actually, on how many database clusters can we integrate with the MCP server. So the nice thing here is you can really scale this up to hundreds of servers without problems. With some organizations using this successfully with hundreds of servers, because oftentimes, once you're drilling down, right, like once you're actually looking at a problem, you are at a particular server anyway, right? And then you can scope it down. And at the high level, if I'm asking, why is my database slow? Then it really comes down to, how do we map the, my database slow question to which database it actually is we're talking about. And so there things help like server tags, for example, right? So in your AWS account, for example, if you add a tag to an AWS RDS instance, that's something that pganalyze will pull in. And so if your instance, has a certain tag that says this is that application team's instance, even though the name might be harder to understand, pganalyze has visibility on that, and it will echo it back to the MCP client as well. And so then the MCP client can zoom in on particular database that way, or just look at, in pganalyze, you have like the kind of all-up checkup, like health check of all databases. And so if there's something going bad with one of the databases, like a blocked query, you could also find it that way. And then last question for today, Samir asked a question. There are different approaches to address performance issues. So you can do query tuning, instance parameter tuning, like fixing a data model, tuning statistics, fixing query plans. What is pganalyze's approach to address performance issues? It's a great question. I think it's a it's a complex question. So I think in my personal experience, and this does translate to what we offer with pganalyze, is I find that often people put too much emphasis on parameter changes. Like there are certain things that do greatly influence query plans, like random page cost, for example. But I do find that, once you've taken care of some of the, standard parameters that people change, which some of the cloud providers change for you already, the one thing I can definitely say is that in my experience, it's less about the settings tuning and it's more about which query plan you're getting and also what information you tell Postgres, right? So for example, the rewrite that I showed earlier, it added a where clause and it added a filter. That's something that Postgres doesn't know, right? Like Postgres doesn't know it's safe to pull in this other column. And so I think a lot of the performance optimization where I've really seen, pretty big performance gains is when you do a better job translating the constraints that you can apply from the application perspective into the query so that Postgres can then do a better job. And this actually is where the AI tools really help us, right? Because they can read the code base and they can say, well, looks like all the callers have this other parameter available. Let's just pass it in, and then we can get better query plans that way. So that's the quick answer. And then one last super quick question. Harshit asked, can we configure pganalyze alerting using this as well? So one thing we're adding actually, like probably in 2 weeks time roughly, is support for webhooks finally in pganalyze. And so one nice thing you can do with webhooks is you can actually trigger sessions from a webhook, right? So one of the things we envision is that you could have a Claude Code session triggered from a webhook so that you can say pganalyze flagged something and then I have my agent investigate automatically. All right. Those were all the questions for today. Thank you, everybody, for joining. Again, fill out the post-webinar survey and reach out if you want to talk more. Thank you, everybody.